we're going to look at one last application of the logarithmic function, and that is decibels and noise level. So the intensity of audible sound varies greatly. And the idea behind a decibel is that that range is so enormous that we're going to consider the logarithm of the sound intensity. So to measure a sound in decibels, we're going to take the sound's intensity, which is represented by the letter I, and we're going to compare that to a benchmark sound. So we'll call that I0 or I0. And that's basically the lowest intensity sound audible to humans. And it's defined to be 10 to the negative 16 watts per centimeter squared. So to calculate those decibels, what we're going to do is we will take our sound intensity and divide it by the benchmark. And we're going to apply the log to that and then multiply that by 10. So that will give us our decibels. Okay, so number 9, the sound intensity of a refrigerator motor is 10 to the negative 11 watts per centimeter squared. Find the decibel rating. So that's going to be dB is equal to 10 times the log. And it's going to be I. So here's my I, the sound intensity for that refrigerator, 10 to the negative 11, divided by our benchmark sound, which is 10 to the negative 16. And that'll be equal to 10 times the log of, this is negative 11 minus a negative 16. So that'll be negative 11 plus 16. We get 10 to the 5th. Log and 10 are inverse functions here. So I get 10 times 5, because 5 is what's left over when I can put those two together. And that tells me that the sound rating here is 50 decibels. All right, number 10, loud music can measure 110 decibels, whereas normal conversation measures about 50. How many times more intense is loud music than normal conversation? All right, so let's start by defining IM. So that's going to be our sound intensity for music. And we can write an equation for that. That's going to be 10 log of IM over I0. Okay, and that's going to be equal to 110. So we have that right there. And then we'll do IC for the sound intensity of conversation. Okay, so that's going to be 10 log of IC over I0, our benchmark, and that's equal to 50. Okay, and next what I'm going to do is I'm going to subtract these two so I can find the difference on my way to figuring out how much more intense this sound is. So if I subtract these two, what I get is 10 log of IM over I0 or I0 minus 10 log of IC over I0 is 110 minus 50, which is equal to 60. Now I can factor a 10 out of both of those logs on the left, and I can divide that over to the other side here. So if I pull that 10 out, I get log of IM divided by I0 minus log of IC divided by I0 is equal to 60. And if I divide that 10 over, what happens is now it's just equal to 6. So I have log of IM over I0 minus log of IC divided by I0 is equal to 6. Now I'm going to use the law of logs to combine these. So I get the log of IM divided by I0 over IC divided by I0 is equal to 6. Okay, those I0s will cancel. So now I have a log of IM divided by IC is equal to 6. And what I want to know is how many times more intense is this loud music than normal conversation. So what I want to solve for is IM divided by IC, okay, to get that ratio. To do that, I'm going to do 10 raised to each side. And 10 and log, or common log, are inverse functions. So I'm left with IM divided by IC is equal to 10 to the 6th. Okay, and 10 to the 6th means that that is 1,000,000 times more intense of a sound. All right, and then last but not least, if a sound doubles in intensity, by how many units does its decibel rating increase? Okay, so I'm going to start with our equation. I have 10 log of something over I naught minus, and I'm looking for a difference here, so I'm subtracting 10 log of something also over I naught. So I'm looking for a double the sound intensity. So if my original intensity was just I of this sound, then 2I would be doubling that intensity. Okay. I'm going to pull that 10 out in front like we did previously. So that gives me log of 2I over I naught minus log of I over I naught. Okay, and we'll simplify that again. So I have 10 times, and I'll use that law of logs to combine those and simplify. So 10 times the log of 2I over I naught divided by I over I naught. So those I naughts cancel, and these i's cancel. So I'm left with 10 times the log of 2. And if I put that in my trusty calculator, well, I'm going to find out that that is about 3.010 decibels. Okay, so if a sound doubles in intensity, its decibel rating is going to increase by 3.